Hello everyone. Today we are going to see a machine learning project that is predict ads click. Problem statement or business problem as follows. In this project we will work on a data set indicating whether a particular internet user clicked on an advertisement. We will try to create a model that will predict whether or not they will click on ad based on the features of the user. So let's discuss about the data. So the first column is daily time spent on site, which indicates consumer time on site in minutes. Age, customer age in years. Area income indicates average income of geographical area of consumer. Daily internet usage. Average minutes of data consumed is on the internet. Ad topic line. Headline of the advertisement. City of consumer. Male, whether or not consumer was male. Country of consumer. Timestamp, time at which consumer clicked on ad or closed the window. Clicked on ad is represented by 0 and 1 indicating clicked on ad. So now let's load the data first. Data loading. We will write percentage scala, which is a magical keyword which tells Databricks that the code which is written in this cell is in Scala. Well, CSV is a variable declared with variable name as CSV. Spark.read.infer schema true, option header comma true, and CSV. CSV is the function to load a CSV file. So this is the location where the file is stored. That is file store table advertisement 1.csv. This is the name of the file which I have uploaded in this location. Header comma true, which indicates the first line of the CSV. It has the column name, that is daily time spent on site, age, area income, daily usage, ad topic, city, mail, country, timestamp, clicked on ad. And infer schema true means the data type and column name will be inherited from the CSV file. So this is the data frame which will be created. CSV.show will display the data. So if I click on run cell, it will execute the code. So here you can see CSV.show. CSV is of type Apache Spark.sql.data frame, and this is the data displayed. So this is how we load the data. Databricks has an inbuilt function called display, which we can use with open and close bracket and ends with a comma. So I will write display CSV, and if I execute shift enter, it will display the data in this format. So the we have a proper representation of the data, not like the above statement where the data is displayed in the raw format. So that's why the display function is used. Now let's print the schema of the data. So here we are writing CSV, which is a data frame created on the first step, that is the CSV. This CSV file we are using csv.print schema will give us the schema name. Let's run it. So these are the column name with the respective data type: double, integer, double string, string, integer, timestamp, and integer. So we can also use select function to select only few columns. So this way we can also write csv.select Specify the column name which we want to display. Describe function will give us count, mean, standard deviation, mean and maximum value of the particular column. For example, daily time spent on count is 1000, mean is this much, standard deviation is this much, minimum value is this much and maximum value is this much. So the data statistics has been displayed by using the describe function, and show will use to display the data. So this is how we find out count, mean, standard deviation, mean and maximum of the data. If I write display and open the bracket and close the bracket after describe and remove the show, it will display the data in the GUI format, more advanced format where we can scroll the data. So here you can see this is how we can use the display function to make the display attractive to understand the data. Same way we can fetch only limited columns and describe the data. So that's all from the data loading point of view. In this section we are going to visualize the data. So for that we will load the data into a temporary view. So I will write CSV which is created on the first statement here. This data frame we will use over here and we will create a temporary view. So here you can see we are creating CSV.create or replace temp view, which means whenever we will close the Spark cluster, this data will be in temporary, it will be destroyed after that. Once we log out from Databricks environment, we will lose the data because this is for temporary purpose. We are creating a temporary view. So as soon as we stop the cluster, this data will be lost, so that we don't use unnecessary data or memory or storage. So that's the reason we will use temporary view. So let's execute it. So here you can see I've executed it by using shift enter. Here I am writing pure SQL select start from adds data. Adds data is the temporary view name. So I will write select star from adds data. So here you can see here data has been displayed. So if I type again select star from adds data. So I want to show you, if we click on plus sign, we can create a visualization. Visualization of various line bar, area, pie chart, histogram, heat map, scatter, bubble plot, box, combo, current, count, detail view, funnel, map, Sankey, sunburst sequence. These are the new types of visualization which Databricks have added. So this way we can create our own visualization with specifying the column name, X column, Y column. So by using the plus sign we can create a visualization. So in order to save time, I have already created a visualization. This is custom plot, scatter plot with all the required column names in the value section. You will get this kind of visualization. So this is how we called we'll call it scatter plot. Here I am generating a histogram with respective to age. If I click on visualization, here you can see display type is histogram plot. So number of beans means this basket is 20 and aggregate by summation. Scatter plot for area, income and age. So here is the scatter plot. We at which age group we are mentioning the average income for that location, and the visualization is being displayed. So you can explore various types of graph. I have also added age and daily time spent on site. This is the graph. So that's all. We will see you in the next topic. So here we end the data visualization part. So the next part will be for machine learning. So in this section we are going to discuss about the machine learning model. So let's directly move into it. So first we need to make it clear we cannot process string data type directly in Apache Spark machine learning libraries. We need to convert the equivalent string to numerical data. So for that we use string indexer, one hot encoder and various options are there. For this model we are using string indexer. So here I have created a variable string feature column, add topic, line, city and country. These are the three columns in string data type. Let's see. So here you can see add topic is of type string, country is of type string and city is of type string. This three column need to be converted into numeric type. So how we will do that? So we will write variable string feature column. We will create an array of these three columns. I will execute the code. I will write an example to make you understand how string indexer works. So this is the import statement. We are importing string indexer. We are creating a variable data frame spark.create data frame sequence 0a 1b 2c 3a 4a 5c 2df, that is 2 data frame, id and category. So if I use this much, let me create a new here we are creating a data frame with column name, id and category. Let's execute it. So here you can see a data frame will get created with id and category 0 1 2 3 4 5. So this is the code I which want to make you understand. This is how we create a data frame by using for to make it understand. So this df we will create a new variable indexer equal to new string indexer. That is this new string indexer function which has takes set input column category, that is this column category in which we have string data type, and set output column as category index. It will create an index for it. Well indexed equal to indexer dot fit. We will fit the data frame over here and transform the data frame so that we get a indexed column. So let's execute it by clicking on run cell. So here you can see a third column has been generated called category index. For A, it has represented 0, B as 2, C as 1. This is the generation by the system itself. We are not generating it manually. So whenever A arrives, it will write as 0 because A has been assigned 0. So here you can see for ID 4 and ID 3, the value of category index is 0. And for C, you can see category index is 1. So this is how the same strategy we are going to use on these three columns. That is add topic line, city and country. So let's do it. So here I am loading few libraries. Attribute, string indexer, pipeline model and pipeline. Here we are using val indexers equal to string feature column, that is these three columns. String feature column. Add topic line, city, country. Dot map column name. New string indexer, set input column, column name. Three column name will be passed over this. That is add topic line, city and country. Set invalid, handle invalid, skip. For some records, if any error occurs, invalid error occurs, it will skip the data. Here also you can skip or bypass. For that purpose we are writing like in Java how we handle event handler, the same way we are using set handle invalids. So here set output column, column name plus index. So we will create a pipeline variable with the pipeline function set stages indexer. So in this we are passing this indexer, and the data frame which we will create is adds final data frame pipeline, that is created over here, fit CSV, transform CSV. So the whole data from this CSV load will be passed in that function. So let me execute it so you can better understand it. So adds final data will be created. So let's print the schema. Adds final dot print schema. So here you can see these are the string column. Adds topic, city and country. It has added three more columns. Add topic line underscore index, city underscore index and country underscore index. Let's execute it. So here you can see three index column has been added to our original data. So the above step is used to add three new columns with index value of the particular respected column. Let me use display adds final df. Sorry. So here you can see at the end three columns have been added. Add topic index, index has been generated, city, country index. So the three columns which were having string data, we have written a equivalent string indexer for it and generate an index for it, so that we can use this column for our model, machine learning model. Adds final dot count will display the number of records. We have 1000 records. Whenever we work with machine learning, we divide the data into 70-30. 70% for training the model and 30% for testing the model. So here we are using val splits equal to adds final data frame. That is the data frame which we created over here. This data frame we will be using for our model because it has 3 new columns which are of string equivalent. So what I will write is random split array 0.7 means 70% and 0.3 means 30%. And this split will have two splits, that is index 0 and index 1, because here the data will be split into two parts. One data will be 70% of the data and one data will be 30%. Here we are train and test count, and we will display the count by using println statement. So let me execute in order to make it very clear. So here you can see 70/30 it has divided by randomly 714 records for training records and for testing 286. So the split is of type array and train is using the split index 0, that is 70%, this is 30% of data test, and here we have displayed the count. So the data has been divided into 70/30. In order to process the data, we need to convert it into vector assembler. So vector assembler means each and every column need to be in type of vector. So here you can see 32.6, 38, 41, 59. Those are the values of the column. Daily amount spent is 32.6, age is 38, area income is 401592, daily internet usage is 190.05 minutes, add topic index is the index number 154, and so on. So this is how vector, we create a vector of it. So we are using vector assembler. For more details, please Google vector assembler in Apache Spark. You will get to know this detail. Or you can also join my Apache Spark machine learning course, which has 4 projects, and complete Spark machine learning has been taught in it. So here you can see we are creating an assembler, new vector assembler, set input column array of daily time spent, age, area income, daily internet usage, add topic index, city index, mail, country index, set as output feature, set output column as feature. So all those data will be written into a column named feature. Well, training equal to assembler dot transform train, that is 70% of data, select dollar feature, that means all the columns, plus clicked on add, that is the column which we are, our main focus is to predict. This is the prediction column on which we are going to predict the result. So we will label it as alias function. We will rename the click on add column as label. So this column, sorry, this click on add column will be replaced as label and other columns will be represented as feature. So feature and label column will be our training data frame. Training dot show false. False will display the complete display. If I remove the false, it will show only limited columns. Let me execute the code. So you will get to know. So if I remove this training.show, it will only show limited. It won't show the all the columns. It will show only limited columns. So that's why show false. So all the column, feature and column, feature and label are the two columns which we need to use for creating our model. So this is the standard way to write a model, machine learning model. So here we are using logistic regression model. Spark ML dot classification logical regression. Well, LR means logical regression model equal to logical regression set label column, that is the label column, this column, set feature column and feature column, set max iterator at 10 and set reg parameter as 0.3. These are the standard values. So we are using those. Well, model equal to fr.fit.training. So the model will use the lr.fit.training. Training is the data frame which we have created over here. So this training data frame will be passed to our model and our model will be trained. Let's execute it. So our model has been training on the 70% of data, and here the model has been generated. So here you can see this is of type LR org.apache spark.ml.classification logistic regression, and the model is of type org.apache spark.ml.classification logistic regression model. So this is the model which will be used for prediction. Now training data is also having a column clicked on ads. So we are again use the assembler, that is vector assembler, and we will transform the test data, that is the 30% of data, test data over here. So here again we are using the vector assembler model and transforming the test data and creating a true label so that we can compare the final results. Click on add and will be replaced as true label. So let's testing model will also. So here we have feature column and true label column. Assembler transform test. Select $feature and click on add as true label. So feature and true label has been created. So now we will write well prediction equal to model. Model has been created over here. Model. This model which we have trained by using training data, this model will be used for prediction. Well, prediction equal to model dot transform testing. This is the testing data which we have created above. So here in simple step, if I discuss about this statement, is to create a feature column, all the columns in one column, that is age, country, all the respective columns have been formatted and made in a proper format. True label is the predict add column, that is 0 and 1. So the click on add column will be replaced by true label. So here by using the model transform testing data, well prediction, select feature, let me remove the probability. This probability will make you confused, so better to remove it. So here we are using well prediction equal to select feature, prediction and true label. So feature is this column, prediction is the column generated by our model, and true label is the actual value in the data frame. predict.show 1000 records. So here you can see this is our prediction 1 1 for all the records. So here let's verify. So our model is predicting very perfectly. So for here you can see for 0 it has predicted 0. Here for 0 it has predicted 1. So here it is, we are not getting the exact value. So even if you achieve 90% accuracy, that will be a huge achievement for our business model. So now let's use an evaluator that will evaluate how good our model is in prediction, whether the prediction value is we are getting is correct or not. So for that, these are the set of lines which are predefined by Spark. Import multi-classification evaluator from evaluation library. We are declaring variable evaluator equal to new multi-classification evaluator function, set label column as true label, set prediction column as prediction, set matrix name as accuracy. That is true label is this column, true label and prediction, and it will generate an accuracy matrix for us, and we will display the accuracy by using evaluator.evaluate prediction. So let's execute the code. So here you can see accuracy we are getting is 0.95, that is 95% of accuracy. So let's use the another model to verify. See, well TP equal to predicted is the data frame which is being generated over here, predicted dot filter, prediction equal to 1 and true label equal to 1, prediction equal to 1 and true label equal to 0 means it is not predicted, that is false positive. True positive means TP, prediction is also correct and true label is also correct. False positive means prediction is 1 but true label is 0. So this is called false positive. True negative means prediction is 0 and true label value is 0. False negative means prediction equal to 0 but true label is 1. So by using this we can create a matrix and generate it. So true positive count we can get is 131 correctly predicted. False positive means 0. False negative, true negative is 142 and false negative is 13. Precision is 1, recall 0.90. So this is the matrix which we generate to verify how accurate is our model. For any doubts, please comment on our video. We will get back to you. So that's all for this lecture. See you in the next video.